All right, so this is one of my favorite activities to do. It's notes, but it's got a lot of thinking on your end, and some corny stories to go along with it. So, Alexandria and Quinn are having a debate. So, after graphing three equations, these guys right here, Alexandria says, "Hey, it looks like these lines they never touch, so they all must be parallel because they don't touch." But Quinn, a natural skeptic, is not so sure. What do you think? So go ahead, take a couple minutes and, oh, all right, here in this space, right? What do you think about what's going on here? All right, so of course, the teachers in the room are going to say answers will vary, right? Anytime you're asking kiddos for input, right? So maybe you're like, yeah, you know what? I think Alexandria is right. Maybe you're like Quinn and you're like, oh, I'm not so sure. So to settle this debate, Quinn thinks that they should compare the equations of the lines, right? But before she can look at them, her ever-spazzing calculator clears its RAM. Rats, right? So she doesn't have the equations anymore. That's okay, because we can find the equations, right? We just finished this chapter, and we can use whatever form we like. So we could use slope-intercept or point-slope to write the equations here. Because they do have all of the y-intercepts, I think I'll use slope-intercept form, but you can use point-slope form as well. And I'm going to go ahead and name these so that we can differentiate between them. So call that one f of x, that one g of x, and this one h of x. Right, so for f of x, it's going to have a y-intercept of 4, a slope of up 1 over 5, so a slope of 1/5. So its equation will look like f of x is equal to 1/5 x plus 4. Okie dokie. Alright, now I'm going to write the equation for g of x. Alright, so it looks like it has a y-intercept of 2, a slope of up 1 over 4, so slope of 1/4. So we got 1/4 x plus 2. Alright, and last but not least, I write the equation of h of x. Alright, so h of x has a y-intercept of 1 and also a slope of 1/4. Alright, let's consider these three equations. What do you notice here about them? Alright, well, I happen to notice that g and h, the slopes are the same. Right, 1/5 is kind of close to 1/4, right? They're both kind of smaller fractions, but g of x and h of x have the same slope. All right, so next door at the next table, Michael and Jack are disagreeing about these graphs. So Jack thinks that he sees two pairs of perpendicular lines, but Michael thinks that there's only one. So he said, just because it looks like they form right angles doesn't mean that they really do. All right, so what do you think? So one thing to notice, right, is how graphs can be misleading. So notice how this is technically 1 by 1 unit, but it's not perfectly square, right? So you can't maybe just eyeball what's going on here. But go ahead and in this space here, tell me, what are you thinking? What do you think is going on here? Do two pairs of parallel or perpendicular lines? We just have one. What's going on? All right, so the teacher and me, of course, gonna say answers will vary here. All right, so again, we're going to write our equations of these. So may I call this one here F, this one G, this one H. We'll go ahead and write their equations. All right, so again, I'm going to use slope-intercept form. All right, so here we've got y-intercept of 3. And a slope of 2, right? It's going up 2 and over 1. So this will be 2x plus 3. The equation for that first one. All right, now let's look at g of x. G of x has this y-intercept here at negative 5. Its slope, let's see, it's going up 5 over 2. So 5 halves x minus 5. All right, and then h of x has the y-intercept here of positive 2. This one has a negative slope, so it's going down 2 and over 5. This will be negative 2/5 x plus 2. All right, so now that we've written these equations, I'm actually going to bring them down here. Oh no, I brought my y with me. Can you put it back here? Jeez. All right, so what do you notice about what's going on here? Something I noticed here about these slopes are that they are opposite. So one's positive and one's negative, and that they are reciprocals, right? So they are one over the other, right? So like example of reciprocals is like A over B and B over A. They're like flip-flop. All right, so let's put all this together and see what's going on. All right, so what I'm going to do is I'm going to sketch a little graph of all three of these. So we're going to talk about parallel lines, perpendicular lines, just plain old intersecting. Because I found that students are kind of confused about whether lines can just make angles that aren't totally right. So this one is kind of crooked. Looks better. Alright, so parallel lines look like this. I don't know about you guys, but I write at an angle, and so then I have to like move the iPad to see what it looks like straight up. Alright, so a couple of things about our parallel lines here. Parallel lines never intersect. Slopes of two parallel lines are the same. and their y-intercepts are different, because if they had the same slope and the same y-intercept, they'd just be the same line, not necessarily parallel lines, right? Because they'd be intersecting constantly, because they'd have every point in common. Perpendicular lines look something like this. Where they're forming right angles. I guess I'll be a good math teacher and I'll put arrows on all of these. Alright, so with perpendicular lines, they intersect in a very particular manner, right, to form right angles, or 90-degree angles. And their slopes are opposite reciprocals. So they're both opposite signs, one positive, one negative, and reciprocals of one another. Right, intersecting lines look like this. They're just making angles that aren't 90 degrees. So they intersect to form non or right, not 90 degrees. They're going to have different slopes. But they could share the y-intercept. So if they intersect to only one spot, it just may be that that spot is y-intercept. Right, if that is the point of the intersection. Alright, so I got some good thinking questions for you today. So I want you to consider how this graph of g of x is going to compare this graph of f of x without graphing them, just by the equations. Then, given this equation h of x, I want you to, and given that it's parallel to p of x, write me an example of an equation for p of x, and then tell me what could not be, right, a non-example, what could not be p of x. So go ahead, take a moment. Okie dokie. So hopefully you try those out on your own. So notice the slopes here, 2/3 and 2/3. They have the different y-intercepts, right? So g of x will be parallel to f of x. Now if h of x has the slope of -2x, and I know that it's going to be parallel to p of x, that means that p of x needs to have the same slope as h of x, but some different y-intercept. So let's say p of x looks like -2x minus 394. So of course, answers can vary because you probably chose a different y-intercept. All right. Last but not least, we're kind of like a non-example here. So I'll just take my answers will vary here. Duplicate that. Bring it down here. But what is kind of a non-example? What could be would not be p of x's equation? Well, it would need to have a slope that's not -2. So maybe I say p of x looks like 3x, right? That wouldn't be, right? And how do I know? Well, it does not have the same slope. All right, there you have it, guys. Parallel, perpendicular, and plane intersecting lines.